Can buildings adapt to the environment like living organisms? What if these structures could reduce stress levels and vibrations by themselves? Picture this, a world where buildings aren't just static entities, but dynamic, living structures that respond and adapt to their surroundings. This isn't a science fiction scenario, it's the concept of active structures. Active structures are mechanical marvels that can change their configuration or properties in response to environmental changes. Think of a building adjusting its own temperature in response to weather changes, or a bridge that can stabilize itself during an earthquake. These aren't just buildings, they're active, adaptive ecosystems. These structures require constant motion and power input to remain stable. This might seem like a drawback, but it actually allows for greater mass compared to traditional static structures. Imagine skyscrapers that are safer and more resilient, or bridges that last centuries instead of decades. Active structures are not just concepts, they are already in use in various engineering fields. Active structures, also known as smart or adaptive structures, have come a long way. These dynamic marvels have evolved significantly over time, largely due to the advancements in aviation and aerospace engineering. The pioneers of these fields saw the potential for structures that could adapt and respond to their environments, and they pushed the boundaries of what was possible. Active structures found their first sophisticated applications in the wings of aircraft and the intricate constructs of space structures. It's quite fascinating when you think about it. These structures, constantly in motion, constantly adapting, constantly consuming power to maintain their stability. Yet, they're not without their limitations. The actuators, the components that control the movements of these structures, are typically one-dimensional. This restricts the design options to active truss structures and manipulator arms. While these are indeed valuable in their own right, one can't help but wonder what could be achieved with more flexibility in design. Active control technology, the driving force behind these structures, has found widespread use not just in the aerospace sector, but also in civil and mechanical engineering. These technologies are employed to mitigate the effects of seismic activity and wind loading, increase damage tolerance, and facilitate deployment purposes. The current applications of active structures are vast, but their potential is even greater. Imagine a future where buildings adjust and adapt themselves to the weather, load variations, and even seismic activities. This is the potential of active structures, the adaptive, resilient buildings of tomorrow. These structures, with their ability to change configuration in response to environmental changes, open a whole new world of possibilities. They're not just smart, they're sustainable. Active structures can contribute significantly to energy efficiency and the decarbonization of buildings. Think of it as a building with a mind of its own, using artificial intelligence to manage energy. It optimizes systems like heating, ventilation, and air conditioning, as well as lighting, to save energy, reduce emissions, and contribute to a greener future. But the potential of active structures doesn't stop with sustainability. They also promise increased safety and resilience, especially in earthquake-prone areas. These structures can adapt to loads, reducing stress levels and vibrations, which can be crucial during seismic activities. The future of buildings is not just about bricks and mortar. It's about adaptability, resilience, and sustainability. It's about active structures. We've journeyed from the concept of active structures to their current applications and potential future uses. We've seen how these adaptive structures, with their ability to respond to environmental changes, are transforming the way we approach building design. From aviation to architecture, active structures offer solutions that are not only innovative, but also sustainable. As we move forward, the integration of these structures with advanced technologies such as AI promises a future where buildings are more resilient, energy efficient, and adaptable to their surroundings. In the face of a changing environment and the need for sustainable solutions, the future of buildings lies in active structures.